Hi, I am Mariano Merchante, and I'm going to talk about an emotion-based framework for procedural music videos. Kind of like a prototype of some of the ideas that I've been thinking about for trying to automate some aspects of music videos. So, before we get into the talk, it would be interesting to discuss what defines a music video. In general, music video is something that is done after the song or the track is already made, and it's usually reverse engineered. Like you have this amazing song and you want to like do some cool visuals for it, and you kind of like try to find the shape of the music, the ups, the downs, the patterns, and then you try to kind of like build something that is cool based on that. A cinematic, on the contrary, usually goes the other way. Like you have some cool visuals and storyboards and like an actual story you want to tell, and then the music in general is designed after that is, or at least in collaboration with that. And also, if we just go to just like music visualization, like stuff like Winamp, or maybe some cool visual stuff with, I don't know, Houdini or Touch Designer or Shader Toy. Usually, most of the common approaches to music visualization are based on frequency, on volume, and on beat analysis. And a lot of times, basically, these are like very straightforward mappings for color, for shape. Maybe with beat analysis, you may have stuff like camera cuts, but in general, it doesn't go further from that because it's really hard. It's a really complicated problem trying to understand a song and its structure just by using the waveform. So the idea of this project is trying to build like a brute force approach that is easy to implement. Can be used for cinematics, maybe. We'll see. And then it would be interesting to see if it applies for styles transfer. Maybe you can have like a scene that can change for a different song, and it's mostly a prototype. So the talk is going to be divided in the following sections. First, we're going to talk about like what emotional model we're using and how to annotate this emotional information, what to do with the signal and with the events. Then we're going to get into camera models, into like an event state machine based on emotion, then into some procedural lighting ideas, and then into like the conclusion and some future ideas. So before we get into the talk, it would be interesting to show you an example of this system working. Please note that it is a prototype. It's a work in progress. There's a lot of stuff that is unfinished. There's a lot of clipping, overlapping. Some cameras make very weird decisions sometimes. It is not optimized at all, so there's some stuttering. So please consider all of this and enjoy the video. Great. So let's talk about emotional models. Of course, emotions are very subjective, and thus they are very hard to quantify. And even if they're related to chemicals and a bunch of like actual hardcore science stuff, the models are really complicated, and maybe they don't really map to what kind of like the tool that we want to build. So looking around, I found Plutchik's wheel of emotion is an interesting approach to emotions. And it kind of has like the same idea as a color wheel, or that comes from color theory, in which there's like emotions that are opposite between themselves, and the neighbor emotions are related, and they can shift around, and depending on the intensity, they can be like a very calm emotion or a very intense emotion. For example, from annoyance to rage, or from ecstasy to serenity, and in between. So when I found this, I realized this is very intuitive for usability. This is really useful for an artist, or for someone that doesn't really care about the science, like just like they want to annotate a specific song. However, I did implement it. Everything can be implemented in an abstract way in case the model needs to be changed. Also, emotion is very culturally dependent, and most of of course, what I built is very Western based, and I'm sure on other cultures the way we perceive and we associate emotion with music is different. So there's this subjectivity still there, and the author that annotates a song is still going to be very important. So, and also like for music, there are other emotional models. Turns out they're also way more complicated and require a lot of music knowledge, which is not the target of this tool either. So another whole discussion, which I don't want to get into it, but defining each specific emotion turned out to be really hard. Talking with people, like I said, oh yeah, like anticipation is like means like this specific thing, and we had like a lot of different discussions with people. So it turns out like even if there's like this interesting emotional wheel, people see different things here. But I feel like it is important to see that there are two main emotions, core emotions, one anticipation and surprise, and they're like intensity variations. And turns out a lot of music is related to this. A lot of like musical structure is related to this, to how you anticipate a specific movement, and then how you get surprised if it ends up being happening, if it ends up happening or not, or stuff like that. Well, the other emotions are there for more like colorful stuff. These two really play a lot on like the rhythm and the structure of a song or of a piece. So how do we quantify this? We can define this in polar space as a sum of Gaussians. So essentially you have a bunch of Gaussians from 0 to 2 pi, and you add them all up. And then you can build like a kind of like a spectrum, kind of histogram structure that is very similar to a vector. So you can have things like projecting an emotion into another. You can get the derivative. You can maybe get the conflict or the dissonance by saying, how much joy and sadness at the same time do I have? Which, by the way, seems like Plutchik's emotional model doesn't really allow for that, but I feel like still there's a lot of it's good if we like let the system kind of figure out what's going on and not like restrict it further. Also, analyzing all this emotional data is a complete different discussion and can become really hard. So at the very least, there's some pattern matching stuff and some important decisions that can be made just by looking at the structure, the simple structure of how the tracks are placed and stuff like that. But this can be improved a lot. So let's first see how the UI works, and then we'll continue talking about emotions. So this is the editor in which we can annotate a specific song. You can see the waveform, and analyze beat that is not currently working completely. And then you can basically add different tracks. You can add as many as you want. You can change their name, and for each track you essentially can define, and you can add different bars and their length and the placement. Let's try to this. They also snap, so it's essentially like a music editor, like for production, but on the other way. It's like more for reverse engineering, kind of like a song. So for each bar, you can define a set of Gaussians, like this emotional model, in which you can define if it's joy, trust, fear, surprise, sadness, disgust, anger, or anticipation. And you can add as many as you want. The graphics want to show it normalized, so that it's easier to manipulate. So each bar has a set of different useful values. You can define if it's not changing, if it's going up or down, or if it kind of has like a spike in intensity. You can define if it's a variant, like if there's a specific element of this bar that is like different from all this specific track. You can also define, for example, if there's like a harmonic progression going on. For example, for the piano here, you can see that it goes from 0 to 1 to 2 to 3, and then it returns. And in specific moments, it doesn't. And this is where the variant kicks in, which is very interesting for the signal processing part, because it increments the intensity, and the camera kind of tries to find these elements to cut. Then you can define like an overall intensity of the bar. So also another thing you can do is, for each track you can define the type, and this is mostly important for the camera. You can define if a specific track is a main melody, if it's rhythmical, or if it's a structural track. So if we check out the structured track, basically this track is going to say kind of like where are the ups and downs of a song. You can see that the first section is all build up, then it keeps going on a little bit, then it repeats itself, and then it goes down. The idea of this track is to be as broad as possible, so that the camera knows, and other elements too, if the general pace of the song is like increasing or decreasing. And actually a lot of decisions are tied to this structural track. So apart from that, there's a bunch of other usability stuff, and you can pre-compute the whole song and try to see how it evaluates in emotion space. It takes a little bit of time. There you go. So now you can basically move around time and see it automatically build like this energy waveform. It kind of shows like the overall intensity of the song, and you can see that it's not smooth. This is mostly because things like the piano keys are going to be very, very, very harsh, but the emotion engine has like a smooth signal of this. And when you play it, you can see the emotion changing with time. And you can see that a lot of the anticipation is tied with the rhythmical elements, the voice is tied with the joy and trust, and then there's like a hidden sadness. Like overall, it goes from sadness to trust and joy, and then to sadness again. Again, this is very subjective, and in the end, it's kind of like a way to build a recipe. It mostly depends on how you also define your visual elements and how you tie them to these emotions. So an interesting thing here is to see that, like a question I had while building this is how detailed should I be with this annotation? And well, I feel that there's a lot of like micro emotion signals, like for example the piano keys. Maybe they're not that useful for the overall emotion, but they give cues to the camera to cut, and this is interesting. And in the end, a lot of these tracks are useful for that. For example, the syncopated bass or some synth, they kind of like, or the drums, they kind of like guide the camera and tell it like when it's a good idea to cut. Also, when looking for events, we will see this further, but for example, you can see that there's a huge change in the amount of tracks that are active at this moment and then at this other moment. So this is also defined like as a structural point. And this also adds to the intensity of the overall curve. So this is pretty much the editor, and let's go back to the talk. Awesome. So now that we have an annotation of the song, now we can filter the signal a little bit. So we can do smooth filtering of the signal with intensity too, not just the specific emotions. This is useful for different coherency aspects of the camera. And then we can implement some basic logic to find when a track is introduced, stuff like if a specific element is first shown and then some time passes and then it appears again, then maybe there should be like a spike in intensity and a bunch of other stuff. This is like an example of the code. I won't get into it because time, but if you want to look at it, the code is going to be up on GitHub. So now that we have all the annotations from a song, now we can work on camera models. So we can do a lot of things with emotions, and mostly with their events. So events are going to guide most of the cuts, actually. We can define intelligent cameras, kind of like what Cinemachine does, and we will define things like the speed of the camera, what elements we want to show, and what type of camera movement. So trying to find interesting cameras is a very hard problem, and we need a lot of information. We need complete information of the scene, we need colliders, meshes, materials, and it's very computationally expensive, so finding an optimal solution is really hard. However, maybe we don't care about an optimal solution, we want some randomness. But before we get into an interesting camera, we need to find interesting objects. And this is where a lot of the annotation comes again into action. The user needs to say what specific elements of a visual element, of a visual object are interesting. And you can define interest points that have affinity, directionality, important factors, a bunch of different things that will make these interest points very dynamic. But basically you need to go to each object and say, yeah, this is interesting to look at from here, stuff like that. Or they also have like some emotional affinity. But only sampling interesting points is not enough. We need to make sure that they're close together and the camera doesn't move away too far. So we need some temporal and spatial coherency. So basically, if you build like a kind of like a cluster grid and you accumulate the importance, you can have kind of like a heat map. So this can guide the heuristic, and you can make sure you only look at stuff that is close to other important stuff. You can see here that around the angel, there's a lot of interesting points to see, and then maybe once in a while the armors align with the weapons. So now that we know what to show, now we need to go back to the cameras, and the question is, if we want to find interesting cameras and we don't want like an optimal solution, maybe we can just brute force it and we can just shoot rays everywhere and try to place cameras and define like a heuristic for all of these cameras. The heuristics want to be based on their position and on their proposed direction. This is going to depend on the object that we want to see, the current of motion, the structure, things like this. But this is very expensive, so you need to basically defer these over frames, and it kind of makes everything harder. The code is more complicated. But essentially, you accumulate strategies, for example, the dolly camera or a zoom camera or an overview camera, and then at the end of the shot, at the end of the previous shot, you actually decide which camera to go to use for the next one. So this is again some example code. You see that it uses some of the emotion spectrum for some of the noise of the camera. Then for the directions, it uses the main interest axis of an interest point. Again, you can check out the code. It's very much unfinished, but it's useful to see as a reference. So now that we have like a position, and it's interesting to see the composition. And procedural composition is something that is not really popular, and there's not a lot of discussion of this. And I feel like it's really interesting. In this case, I implemented like a rule of thirds kind of thing. It tries to align stuff to one of the lines. It also tries to move around the main axis of movement. It doesn't, but it should also try to get the field of view and try to find like the perceptual size of objects. And then an interesting thing is that it checks it not only checks the importance of the object that you're looking at, but also of the importance that is on the background, that is seen on the frustum of this camera. And we'll see that, for example, in cases like this, the camera really liked to watch stuff from the floor, because on the floor it could see all the arrows, and it felt that because of that it was a more interesting shot, which it is. Like, it's not that it's wrong, but the thing is that the only thing that it did was look at arrows. So it requires a lot of tweaking. And then potentially would be really interesting to use machine vision to try to find lines and angles and patterns and shapes and contrast to try to readjust the camera. But this is very expensive for real time, because essentially you need to analyze the rendered image. So now that we have all of these, we need to know when to cut. And this is where all of the discrete events come into play. You essentially check out their intensities and their emotions, and based on that, you make decisions. You can find repetition, you can find motives. This is very much an open problem, and I feel like there's a lot of different strategies here that could be interesting. Again, it tries to find structural points. For example, if there's a climax, then it decides like, yeah, I should cut here. There should be something, I should show something interesting here because this is the climax or the lowest point of the song. Or for example, what's the length of a shot when in fear? Stuff like this is really interesting. And using this framework, it kind of opens up the possibility of discussing these kind of things. So then, with respect to the scene itself, it's essentially a state machine. Each object has an affinity towards a certain emotion, and depending on a bunch of transitions and triggers, it can move around from one state to the other. And all of these states will trigger certain unity behaviors. This is very much like Mechanim state machine. There's nothing fancy about this. There is, however, a set of interesting triggers, such as like if the song is happy and I'm sad, but I have transition that goes from sad to happy, then maybe I should transition. Stuff like based on the time or on the track that is currently playing, things like this. But while composing all of these state machines and transitions, you can build very complex behaviors and emergent behaviors too. In the case of the camera, then going back to the camera, we should also in the future see when a state machine is going to get triggered. But the problem with this is that it's really hard because you need to basically re-simulate the whole thing in the future. This can potentially take a lot of time. So just a simple approach is checking the affinity in the future, just doing a dot product between the emotions, and with that you can basically estimate if it's going to get triggered or not. And on top of this, the actual scene is built with a procedural level kind of tool that I built a long time ago. This is not really relevant. It's just like a random element placer. It has a bunch of interesting uses, but essentially this can be done with Houdini, with a lot of different tools, plugins, frameworks. But the point is that if this procedural plan, level plan changes, then the whole camera system is going to adapt. And that's, I feel, like the interesting aspect of all of this. And last but not least, the lights are really interesting, and I didn't have the chance to work more on this. I had to basically build like a very simple, naive light. But there's a lot of interesting things with procedural lighting, and I feel like you can probably force the current lighting based on the interesting points that you're showing, and you can kind of like make sure that there's enough contrast, or that there's a highlight on a specular material, stuff like that. I guess you can make very simple, straightforward things like sun and sky. If it's sad, then maybe it should be night. If it's happy, it should be sunrise. Stuff like 3-point lighting or dramatic lighting when there's a lot of intensity. I feel like this could be interesting to work on. Again, such a lighting director should also know about color theory. But again, I feel like just doing a straightforward relation, like mapping from, oh, sad is blue, happy is red or warm, like what I did with the video, is not enough. I feel like there should be more knowledge associated with it. Should know about materials and the responses. So I feel like this is really an interesting project. If you want to work on this, like this is a nice small personal project to work on. But again, this is a very simple prototype. There's a lot of stuff and very small decisions that I didn't discuss, and a lot of this is not completely implemented, of course, but there's a lot of opportunity here because you can build basically a tool that can prototype storyboards or color keys, and you can basically reveal them with a click and say, oh, I like this camera, I don't like this camera, try to rebuild only this camera, or maybe can we take this shot out and like place 2 there. So maybe it would be interesting for like kind of like an idea generator. Or you can also transfer the style of a video from one song to another, or you can also even do like a cinematic thing for a game if you annotate everything with emotion. I still feel like composition is interesting to analyze further, but in the end, while doing this, this idea that this is basically a glorified recipe kept coming back, and I feel like, yeah, it is. Like, you won't see anything that is new while doing this, because you essentially build all the content that you're going to see. However, the synchronization, the coordination of it may be interesting, and I have had some surprises from the cameras that I built. But suppose in the future you have an automatic analyzer and you have like a huge library of visual elements, and you build like this set of camera strategies. Maybe you can completely automate the process of like a small, naive kind of music video from just a song that you throw to a system. So that's kind of like an artist in a box kind of thing, and it's like it's very hard to do this, but it would be interesting to see where it goes. So in conclusion, this is a very simple, naive brute force model. There's a lot of tweaking required because there's a lot of randomness, but the results can be interesting every now and then. And again, there's not going to be any content that you didn't build unless you force the state machines, you design the state machines so that they have some emergent behaviors. And there's a lot of interesting problems to solve and to discuss. So again, the code is going to be on GitHub. If you're interested in this, please contribute, discuss. I'm really interested in this. I feel like this is really cool. So yeah, that's it. Thank you very much.